Hi everyone and welcome back to a new video. So in this lesson we are going to learn all about band composite or composite bands using Landsat bands. So first thing first, what is a band composite or a composite band? In remote sensing, satellites and other platforms use sensor to capture data across various wavelengths of the electromagnetic spectrum. So simply, you can say that each individual band represents a specific range of wavelengths in the entire electromagnetic spectrum. Now, the question is, why to use a band composite or a composite image? So, the thing is, combining multiple bands into a composite image can enhance certain feature or provide additional information that may not be apparent in a single band. For an example, combining visible and infrared bands can highlight vegetation health, while combining different bands such as thermal infrared can reveal temperature variation across the landscape. The composite bands are commonly used in remote sensing applications such as land cover classification, environmental monitoring, agriculture, and urban planning. So let me explain a bit. So as you can see, so I have opened Google Earth and I have simply selected a random region as an area of interest. I am pretty sure everyone is familiar with this kind of image. So in this image we can see this is a river. This are some sort of agricultural land. This deep green patches probably a forest or a vegetation, and that's it. We cannot pinpoint anything more precise in this image. Here comes the significance of a different band composite. We will learn how to create band composite and how to use it. So let's get started. So to create a composite image, first we have to add the Landsat bands here. So I will go to the add data and I will simply add the Landsat band from here 1 to 7 and I'll click add. So these are the bands, 7 bands we just added in our workspace. So as you can see, if I go and open the properties from a single band, under the source tab it says number of bands 1, and this is not for this only, this is for every band. Go to the properties, under source tab 1 band. So these are individual bands. These all bands are individual in nature. So in order to create a composite image, we have to combine these 7 bands together. To do so, we will go to the art toolbox. Then we will go to the data management tool. From here we will go to the raster, then raster processing, and from here we will create the composite band tool. Or you can do it from here, from search pen. You will just have to type composite band and press enter, and this dialog box will open. Simply click here. And here it says input raster. So in order to create the composite, we have to input this 7 band here, and we will prefer the output directory, and we have to name it .tif will be the extension because it's a raster file, and save and OK. So our composite image is ready. So for the time being I will remove this layer, and in the new output.raster, if I go to the properties here, and here number of bands are 7 because we combined all the individual 7 bands and created this new raster. So in the new raster there are total 7 bands. So there are plenty of band combination out there, but the first and important band combination is a true color composite. But before creating a true color composite, let's look at the Landsat band information first. So we have combined the 7 individual bands, and these are the 7 individual bands. The band 1 is aerosol, then blue, green and red, then near infrared, shortwave infrared 1 and shortwave infrared 2. So in order to create a true color composite or a natural color composite, we have to combine the red and green and blue band, and the combination is going to be the 4-3-2, that means red, green and blue. So let's do it. So in the red channel we will add band 4, in the green channel we will add band 3, and in the blue channel we will add band 2. So this is the natural color or true color composite. We can adjust the symbology and go to the stretch, and from here we can adjust it. So it will look much better. So this is the true color composite. Because the visible bands are used in this combination, so the ground features appear in a color similar to their appearance to the human eye or the human visual system. So in here, if I zoom in, so the healthy vegetation is green here, and the recently cleared field or lands are very light in nature, and the unhealthy vegetation is brown and yellow. The roads are grey, and the shorelines, which is around here, you can see these are white in color. This band combination provides the most water penetration and superior sediment and bathymetric information as well. It is also used for urban studies. So if I zoom in this particular region, you can see some fields are green, dark green, then light green, some fields are white, and this is the shoreline, which is white in nature, and this is the settlement here, urban population, you can see, and these are the sediment. You can see the closer the land, the sediment quality or the sediment quantity is higher. So this is basically the true color composite, and you can discriminate certain features with this combination. So the next combination we are going to use is often called a color infrared or a false color infrared composite. So the combination is going to be 5, 4 and 3. Let's look. The 5 is going to be the near infrared, the 4 is going to be the red, and then the green. So what we are going to do is, in the red channel we will assign band 5, in the green channel we will assign band 4, and in the blue channel we will assign the band 3. So this is our color infrared or standard false color infrared rather. So in this combination, vegetation appears in shades of red. The urban areas are cyan blue. So if I zoom in this particular area, you can see the agricultural field or the vegetated areas are red, but all the areas are not same red. Some areas like this area are a bit more darker red than these areas, and the urban features like this settlement are a lightly cyanish blue color. The roads are grey and the soil appears from dark to light brown. So as you can see, if I zoom in here, you can see the soil are grey or brownish in color. You can clearly see that. Then the densely vegetated area or forest area will appear darker red or darker brown in color than the normally sparse vegetated area. This is a very popular band combination and is very useful for vegetation studies, monitoring drainage and soil pattern and various stages of crop growth. Generally, deep red hues indicate broadleaf or healthier vegetation, and lighter red signify grassland or sparsely vegetated area. Densely populated urban areas are shown in light blue. If I zoom out and then zoom in here, you can see these are the densely populated area. These are a very light blue in color, and this band combination gives result similar to traditional color infrared and aerial photography. So this is what standard FCC or standard false color composite looks like. The next band combination we are going to use is called agricultural composite. So the combination is going to be the short wave infrared one, then near infrared, and then the blue. So 6, 5 and 2. Let's assign. You can see the color is completely changed now. So first thing, this band combination is very useful for monitoring agricultural crops. So if I zoom in, so bright green represent vigorous healthy vegetation. So the brighter the green, the healthier the vegetation, while the non-crops such as mature trees appear in dull green like these areas. These areas are probably mature trees or big trees, so it's dull green. Compared to these areas, these are light green. So these are agricultural lands. So the coniferous forest appear as dark like this, rich green, while the deciduous forest appear as a bright green, and the sparsely vegetated and bare areas appear brown and mauve in color. So if I zoom out and then zoom in again in this area, you can see these are the agricultural land. These are light green. These are probably mature trees. So these are very dark green or dull green in color. So the bare soil and bare field or recently harvested field are brown and mauve in color. And if I zoom out and zoom in this area, you can see the populated areas are light purple in color. The next combination we are going to use is also called a land water combination, and the combination is first the NIR or near infrared band, then the shortwave infrared band, and then the red band. So 5, then 6, then 4. So we will assign 5, then 6, and then 4. So this band combination good for picking out land from water. As I said, in this combination you can clearly discriminate the land from the water. In this false color image, land appear in shades of orange and green. You can see this area. These areas in orange or in green in color, and eyes stand out as vibrant magenta, and water appear shades of blue. Okay, so we can see the water here is dark blue, then light blue, then purplish blue, and the lands are here orange or green in color. And let me show you one thing first. If I go to the 4, 3 and 2 combination, this is a true color composite. Look, if I zoom in, you cannot see the water features around here, the water bodies or the ponds. You cannot discriminate from the land. But in this particular band combination, which is 5, 6 and 4, you can clearly see the land and water are clearly visible in this band combination. So if you have to let's say for any analysis you have to pick up only the water bodies from this entire product, you can clearly pinpoint those water bodies in this band combination. As you can clearly see, the smallest of water bodies around here are clearly visible in this band combination. The next combination we are going to use is also very useful for vegetation analysis. So the combination is going to be first the shortwave infrared one, then the near infrared, then the red. So 6, 5, 4. So we will assign 6, then 5, and then 4. This band combination provides and color contrast. Healthy vegetation is bright green. So if I zoom in this area, you can see these are the healthy vegetation. So these are very bright green, and the soils are mauve. So you can see these areas, the bare soils are mauve in color. The band combination is very useful for vegetation studies and is widely used in the areas of timber management and pest infestation. So if I zoom out and zoom in this area, you can see in the forested region, you can pinpoint these are probably matured forest areas. These are very dark green. Compared to that, this is probably agricultural land. This is light green, and these are probably some bare soil which is brownish or pinkish or mauve in color. And the water bodies around here is also very clear. And if I zoom in this area, this is the last band combination we are going to use is also referred as atmospheric penetration. So the combination is first the shortwave infrared 2 or the SWIR 2, then the shortwave infrared 1, and then the near infrared. So 7, 6 and 5. So let's assign 7, then 6, then 5. So as you can see, the 7, 6, 5, if I go to the Landsat properties here, the 7 is shortwave infrared, the 6 is shortwave infrared as well, and then the fifth band is near infrared. So no visible bands are used in this combination. So as in this combination no visible bands are used, it provides the best atmospheric penetration. Let me zoom in. So the coastline, which are here in this case, and the shores are well defined. You can see, we can accurately see the shorelines and the coast in this combination, and it may be used to find textural and moisture characteristics of soil. So this combination is also very useful for moisture content estimation of soil, and the vegetation appears in blue, and this band combination can very useful also for geological studies as well. So you can see the built up areas in this combination are brownish or yellowish in color. The water bodies is dark or black in color. The bare soil are yellow, and the healthy vegetation is blue, and the shoreline is well defined in this combination, as I told earlier. So basically there are more band combination out there, and if you have a proper understanding and knowledge of these bands and this band combination, you can use it in your own analysis. But these are some basic band combination I tried to show you guys. If you guys want a detailed video about why this different band combination works in a different way, you can comment in the video, and maybe I will come up with a new video. Until then, hope you learned something new. Have a great day.
Thanks for watching. Please do like, comment and subscribe to see more content like this. Have a good day.